Right down Convent Lane.
So just this past weekend, I was driving because
You were driving? What? Get off the roads!
No.
Oh.
Just recently, I got my permit.
I thought he was like,
So look,
hey.
about time.
Look.
He was like,
But look,
girl,
so,
down for sure.
I was driving, and somehow I ran a stop sign and I ran a red light.
Isn't that
At the
so
same
funny?
time?
Yeah,
Like,
stop
it's
sign
so
and a
weird.
stop
Yeah,
light.
that's like don't stop.
Whoa, that's like 2 tickets.
And then when I was heading home, the police began to
I know that feeling. You know, every once in a while you do those kind of things and you're just like, I can't believe I just did that.
My mom was actually moved along. I didn't want to tell her that I was zoning out as I was driving.
I do that all the time. It's like autopilot.
I know. That's why eventually we're going to have these self-driving cars.
Literally, the other night I was driving home and I couldn't see the red light because I just couldn't see it. I was driving, and I ran the red light. I actually ran 4.
Okay, what shape is the one that I have drawn the arrow next to? What shape is that? Y equals 2x plus 7. Can you? That is a line. Thank you very much. What shape is this one? Y equals negative x squared plus 2x plus 7. That is a parabola. Okay, so we're going to be graphing these two things. Now, way back when we were graphing systems of linear equations, we would say something like solve. And when you had a line like this and a line like this, what were you looking for? Yes, sir. We were looking for the place where the two lines crossed. And sometimes they crossed like this in one place. But what if they were parallel lines? What would your answer have been when they were parallel lines? No solution, right? And then, of course, we had the last situation where the two lines were the exact same line, and that meant that there were an infinite number of solutions. Well, in this particular case, we have a parabola. Does anybody know if this thing opens up or opens down? It opens down. So we got a parabola that looks like this. What if the line when we graph it does this? Then that would be a no solution situation, right? Okay. Well, what if the line did this and it just nicked it? That'd be a one solution situation. What if the line did this? So we could have a similar situation where we have one solution, two solutions, or no solutions. Okay? Could be a very similar situation. We're going to graph it and find out. I'm going to make a suggestion that you start right now with the line. Y equals 2x plus 7. Go to your graph and plot your line. Y equals 2x plus 7. 7, right? Y-intercept is 7. Slope is 2, so that's up 2 and over 1. But that's going to run off the graph if I keep going to the right, so I probably better follow the same pattern and go in the opposite direction and graph my line. If it bothers you, I do have rulers that you could use during class if it really bugs you that your lines aren't perfectly straight. I totally understand that. Sometimes it definitely comes in handy. Okay, how do we graph this other parabola? What do we need? There was a fraction that I taught you last week, or maybe even part of the week before that, where we talked about how to find the vertex of the parabola. What was that fraction that we used? Negative b over 2a. So in this case, that would be the opposite of 2 divided by 2 times negative 1. So what number are we dealing with for x? That's a positive 1. So my vertex is going to start with a 1. How do I find the y value? Plug this in where? Oh, over here. Go ahead, plug it in. Find the y value that goes with it. Then, of course, you're going to need the 1a, 3a method of graphing. And since 1a is negative 1, 3a would be negative 3. So find that second part of the vertex. Use the skills we've talked about before to graph the rest of the parabola. Case the cocoa's out there. Wait a second. You plugged in 1. What did you end up with? Where are these points coming from? Okay.
But there's another negative thing.
Okay. Yeah. Okay. All right. That's a good idea. Like this. Yeah, it's going to be different. So you're going to have to do like parentheses, negative squared, and then multiply by negative 1. So yes, it is kind of, it's very much old school. If you're okay with that, it's fine. Yes, yes. And this gives me, wait a second. Still gonna get negative 1.
Yeah.
Okay.
That's like,
Then you will get negative 2 there.
No, hold it. If you was like, yes, it is. Yes. It's still.
Whoops.
You can right here. Is minus part of that is
Okay, so when we plugged in a 1, the first term is negative 1, the second term is positive 2, the last term is 7. So what is negative 1 plus 2 plus 7? It's bigger than 6. Negative 1 plus 2 plus 7. That is 8. Okay? Now, if you got 10, I think that you didn't get a negative 1 for the first term. Why is my door propped open? I don't know. I'm going to have to fix that. So we've got a vertex at the point 1, 8. Yes, I'm glad you agree. Now, if I'm using that 1a, 3a method of graphing, that's over 1 and down 1. Over 1 and down 3. We can use those points and find points on the other side that match. What happens? Say it louder, Mr. Glancy. It touches in only one point. The line hit the parabola one time. In other words, the line glanced off the parabola.
Well, that was so good.
Hit me like sun breaks.
What was the other way?
I had to. I just did.
I really thought it was there.
Tell me what? Tell me what? Did you see them running? No, I don't. So what's the place that they intersect at? 0, 7 is the only place where they cross. That is the answer to this question. Yes, what's your question? No. 0, 7 is the only place where they connect. All right, let's try. Go down to question 11. I want you to practice with number 11. Okay? Flip in your packet to question 11. It's easier to read closer up. Graph the line first. Graph the line first. Yes, I do want you to graph the line first. Whoa. It's like an echo in the room. I'll have none of that. Okay, so we got the line. Is that right? You lost. Are you at number 11? So graph the line. Or the parabola. So find your y-intercept first. Y-intercept is a positive 1. So up 1. Put your first dot. Now go with your slope. Up 4 over 1. Anybody struggling with graphing either the line or the parabola?
Do you use that one for the A or do you just use one?
If you're doing anything, you would use 1 for the opposite of 2A.
No, not that. For like graphing, like the 1A.
Oh, the 1A? Yeah, that comes back here. Yep. You got the line? Good. So if you use your opposite of B over 2A, so your opposite of 4 times 1. Find that value. That would be the first part of the vertex.
Oh my gosh, my hair looks like those noodles from Chinese restaurants.
Well, I'm just going to do the line part because I'm pretty sure most of you got that.
Really?
What? She's doing the wrong problem.
I'm doing number 2. And I still don't. You did the X right. Yeah, that's this one. I'm actually offended.
So what'd you guys get for the opposite of 4? That is correct. The opposite of B over 2A is -2. And when you plug it back in, negative 2 squared plus 4 times negative 2 plus 1. 4 minus 8 plus 1 is how much? Negative 3. So we should be starting our parabola at that spot. What is the a value? Because we're going to need it here. 1a and 3a. What's 1a? 1, and what's 3a? 3 times that amount. Wow, I can't talk. 3a. Well, it's a different letter of the alphabet. Negative 2, negative 3. And then if we use the idea of 1 over 1 up, 1 over 3 up, right? We're just going over, 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 over. How many answers do we have here? Okay, what are they? 0, 1. Negative 1, negative 2. I'm going to verify this, okay? Y equals, it's x squared, is it plus 4x plus 1? And then just y equals 4x plus 1. Okay? Whoops, sorry. Negative 2, negative 1. Or negative 1, negative 2. Sorry, that's does not look like a good solution. It looks like there's only one place where they cross. Negative 1, negative 2 does not look like a solution. But back on my picture, it did. Which means what? My graph might be wrong. Or I might just be really sloppy at graphing. And that's a possibility here, folks. So maybe I need to be real careful when I'm graphing that I realize that it's going to be real close. And I think I just got real sloppy when I graphed it, that as this comes down and hits that point, it misses the rest of it. So be careful. In fact, my green one should hit that point and go up like this and completely avoid the orange line again. Be careful when you graph on some of these, because that is not a good solution. There was only one place where they crossed. Now, how could I verify this? Most of you will not like my answer to this question. You could come back up here and you can plug in negative 1, negative 2 into both equations and see if it works. Guess what? It won't. So you could do that. It might work on the parabola, but it won't work on the line. Okay, let's go back up to question 2. Back up to question 2. This time we're no longer graphing. Okay, we got x squared plus 7x plus 10. What's the other one? Negative x plus 3. Okay, folks, how many answers are we going to get to this question? 2. The picture shows 2. We need to find 2 equations, or 2 coordinates where these 2 cross. And we're doing substitution. So, what do you think I'm going to do with this negative x plus 3? Plug it in for y. So, negative x plus 3 equals x squared plus 7x plus 10. Well, there's only one way to solve these quadratics, and what's the first step to doing that? No, you're exactly on the right track. Push everything over to one side. What would that leave on the left side if we pushed everything over to the right? 0. That is an absolute requirement here. So if I pushed the x term to the other side, how many x's would I now have? 8, right? Because you have to add an x. So you suggested we subtract 3, and if I take that away from 10, I get 7. You have two logical choices right now. Those two logical choices for solving this would be, can you name either one of them from last week? Factoring and the quadratic formula. We've written the quadratic formula on the board, and hopefully you have it all over your notes. Factoring would actually be the easiest way to do it, but you take your pick. I'm not going to force you to do one or the other. Factoring or quadratic formula, you choose. But right now you need to make a choice and start working this out. Remember, we already know that there are going to be two coordinates where they cross.
You heard anything you said in the class 2 minutes?
I've seen several of you using either method. Some of you like factoring, some of you hate factoring. So you go with the quadratic formula. Those of you who did factor found two numbers that multiplied together to give you 7, but added up to 8. And so you got this, x plus 1, x plus 7. Now since it's equal to 0, what are you going to do with each one of the factors? Each one of the factors gets set equal to 0, and so what do you get for x? -1 and -7. Now, that's what you would get if you factored. Now, obviously, that's not finished. But if you chose to go with the quadratic formula, which some of you did that, you would have b squared minus 4 times a times c, and 64 take away 28 is 36. So that would be the first step of your quadratic formula. And then your second step would be the opposite of b plus or minus the square root of, and then you got your 36, all over 2 times a, which is 1. And that's -8 plus 6 over 2, and -8 minus 6 all over 2. Now be careful, if you're typing on a calculator, you can easily come up with answers that are not correct. I mean, for instance, what's -8 plus 6? And so we could write this as -2 over 2, and guess what? That's -1. What's -8 minus 6? -8 minus 6. That's -14 all over 2, and that is my -7. Be careful when you're typing on a calculator. I always hit enter after I figure out the numerator, and then I divide by the denominator. And some of you don't want to do that. You want to do it all at the same time. If you're going to do that, you better be using parentheses, right? Parentheses around stuff like this to do that. But I'd say be safe and just hit the enter button after you type the numerator and then divide. Okay, so what am I going to do to find the y values? No matter whether I did factoring or the quadratic formula, what am I going to do to find the y values? Plug it back in. Do you have a favorite equation that you'd like to use? Would you like to use the parabola or the line? Which one? Oh yeah, definitely the line. My goodness. So much easier. Right? So if I take the opposite of -1 plus 3, and then I'll have to do the same thing for the other one, the opposite of -7 plus 3. What are we ending up getting for these? What is the opposite of -1 plus 3? 4. And how about the opposite of -7 plus 3? 10. Now let's go see if we're right. Whoa. Stop doing that. Yeah. Nice job. Almost like I typed it at the beginning of the question. While you weren't looking. I know. Yeah. Okay, question 3. Substitute. You need to practice. Take this and substitute. Push everything over to the right side, setting it equal to 0. If I did, I would have x squared plus what? 3x, good. Plus 2. That's true, right? 5 take away 3 is 2. Now you've got your choices. Quadratic formula or factoring. I'm going to work it out while you guys are working it out and see if we agree here before the end of the period. Make sure once you get your x values that you plug them back in to find the y values. Anybody factor it? If you factored it, what did you get for x? If you factored it, what did you get for x? You gotta have a choice. This is where your notes are falling behind. What was your choice if you factored it? -1, -2. Hey, that's the same thing we got if we did the quadratic formula. Right? Because we got a discriminant of +1, and then we plugged it in. But yeah, we got -1 and -2, and then we plugged it back in to get the 5 and the 4 that go with them. The 5 and the 4 that go with them. Are there any questions on how we did that one? Or any part, or you didn't get the same number, you want me to look at yours? Okay. Good work today. We'll keep going tomorrow.